Hello everyone, my name is Huang, a doctoral student at Southern Medical University. Is currently mainly engaged in liver disease research with integrated Chinese and Western medicine. Today, my topic is about Lupeol, ameliorates LD-induced acute hepatic damage by suppressing inflammation and oxidative stress through TGF-beta1 and NF2 signal pathway. Acute hepatic damage is a severe condition characterized by inflammation and oxidative stress, which is a serious threat to people's life and health, but there are few effective treatments for acute liver injury. Therefore, safe and effective therapeutic approaches for preventing acute liver damage are urgently needed. Lupeol is a natural compound which has significant antioxidant and anti-inflammatory properties in liver disease. However, the protective mechanisms of Lupeol against acute liver injury remains unclear. Here, we used zebrafish and mice to investigate the effects of Lupeol against LD-induced liver injury and the underlying mechanisms. First, we found Lupeol alleviates LPS-induced liver injury in zebrafish. Here, we used the survival rate, body length, heart rate, and morphological changes of zebrafish embryos to investigate the toxicology of Lupeol. And zebrafish embryos were treated with Lupeol for 72 hours. And based on the results, we found that Lupeol was toxic to zebrafish at a concentration of more than 200 more. Thus, we selected Lupeol concentrations of 25, 50, and 100 more for further zebrafish experiment. And next, we found Lupeol inhibits the liver injury induced by LD in mice. D-GalN injection is a common method to establish acute liver injury model in mice. Here we used it as formal research reported. As shown in HE staining, we found that the livers of the model groups showed diffused necrosis, swollen hepatocytes, and severe hemorrhage compared to those of the control group, and Lupeol could reduce liver necrosis. In addition, serum ALT and AST levels were significantly increased in mice under LD injection, while the levels were similar to those of the control group after Lupeol treatment. Thus, we found that Lupeol could restrain LD-induced inflammatory responses in zebrafish and mice. Here, we detected VCAM1 and adhesive molecule activated by TNF-alpha recruits leukocytes to injury site to initiate inflammatory response, and we found Lupeol treatment effectively reduced the expression of VCAM1 in zebrafish. Similarly, we also found that Lupeol reduced VCAM1 in mice, and further we found that the admission of Lupeol could significantly decrease the expression of TNF-alpha and the inflammatory cells such as macrophage and neutrophils. They are labeled by F480and LY6G. Next, we found Lupeol accumulates LD-induced oxidative stress in zebrafish and mice. We used MP3 to detect the level of NOO, and we found Lupeol could reduce nutrient stress. Last, we found that Lupeol reduced the LD-induced liver injury through TGF-beta1 and NF2 pathway. By down-regulating the expression of TGF-beta1 and up-regulating NF2. In general, other experimental results provided the support and that Lupeol effectively protected against LD-induced acute liver injury, while suppression of inflammation response and oxidative stress, which are largely dependent on the up-regulation of NF2 pathway, while down-regulating TGF-beta1. Thank you.